Welcome. What we're going to do now is look at what happens when we use forces. So, forces in motion. If an object is stationary and an unbalanced force acts on it, it will start to move. If an object is moving and an unbalanced force acts on it, then there are three possibilities. Either the object can speed up, it can slow down, or it could change direction. That's if there's an unbalanced force. So this is what forces do. They change the motion of things. In which direction, if any, will the following stationary objects move? Well, it's stationary, there's a force up of 10 newtons, a force down of 30 newtons, so it will accelerate downwards. This one has a force up of 10 newtons, a force down of 10 newtons, so it will stay still. This is 45 newtons up, 30 newtons down, so it will accelerate upwards. Here we have 30 newtons and 25 newtons. There's an unbalanced force of 5 newtons to the left, so it will accelerate to the left. Let's take a car. 1,000 Newton force pushing forward, which is the thrust. So we start the engine, the foot is on acceleration, what happens? There's an unbalanced force, so it's going to accelerate. What happens after 60 seconds? Don't forget we have to label the thrust. After 60 seconds there is a forward thrust of 1,000 newtons. Also there's a thrust as a force backwards of friction of 1,000 newtons. If we add up these forces, the forces are balanced. So what's going to happen? It's not going to accelerate anymore. The thrust is balanced by the friction or the air resistance, so it will not accelerate. It will stay at a constant velocity. Here we have a faster car. You can tell it's faster. Look at those go faster stripes going there. So at the start, there's a force pushing forward, the thrust of 2,000 newtons. This is the thrust. When it's going at its top speed, it's going at 2,000 newtons forward, but it's not getting any faster, which means there must be a force pulling backwards also with 2,000 newtons, which will be the friction and the air resistance. This is the thrust, and this is the friction and air resistance. Right, here we have the blue car again. There it is. Now we have 1,000 newtons forward, 1,000 newtons back. So 1,000 newtons thrust and 1,000 newtons of friction. So what happens if you take your foot off the accelerator? Well, the thrust will not be there anymore. We'll only be left with one force, which is backwards. It's moving forward to the left, but there's a force acting backwards, so it's basically going to slow down. There's only one force acting on it, so it's going to decelerate. What happens in the next picture? 5,000 newtons. Well, why should it go up to 5,000 newtons? There must be an extra force making it go backwards in a backwards direction. It's still moving forward, but there's a force which is slowing it down a great deal. And I guess the driver has put his foot on the brake, so there's an extra amount of friction there. This plane is accelerating forward. You know, vertically, the lift is balanced by the weight, so vertically it stays in the same position, but horizontally, the thrust is greater than the drag of the air or the air resistance. And since there's a net force going forward, the acceleration must be positive. It's moving to the right. It's accelerating to the right. Now you need to know about Newton's first law. And when you look in the textbook, it says, every body will be either at rest or have a constant velocity until acted upon by an unbalanced force. Another way of looking at it is a body at rest and a body at constant velocity are basically the same thing. Who's to say it's moving? Who's to say it's at rest? Think about being on a train. You're sitting on the train, which is moving, but you don't feel that you're moving, but you're actually travelling at a constant velocity. So you don't feel any strange forces. If you were to accelerate or to brake, then you would feel the forces. So basically being still and having a constant velocity are basically the same thing. Here we have an example of Newton's first law. We have a little blue truck here with a little red ball on top. they both move to the right at a constant velocity, but then the blue thing stops, but the red one just carries on because there's no force stopping it. This is an example of Newton's first law. The red ball carries on at a constant velocity. The blue one is stopped because there's an external force which makes it stop.